Okay, so let's start this third seminar in information systems. Uh, yeah, so I would like to thank everybody that's attending the seminar today. I see some new faces here around, and I'm still playing a little bit of the moderator. So I'm still allowing people to get in. So it might be a little bit tricky to do it, but that's right. Okay, so today we have a call about coronavirus, né? COVID-19, sorry. And it's going to be about mobility analysis in the 2020 COVID-19 pandemic. And the talk was expected to be done by Leonardo Bacelar, which is a guy from the National Center of Disaster Monitoring and Early Warning Systems here in Brazil. But due to some other matters, he was unable to do it. So I invited Vander Freitas to do it, which is the main author of the paper that you have read for this seminar. And first of all, I would like to thank Vander. I invited him just to give you a brief context of the problem of the issue. I invited Vander around 2 p.m., which is 2 hours behind. And he was happy to do it. He accepted the challenge and he prepared some slides for doing it and accepted the challenge to do it in English as well, because some people are not used to it. And thank you very much, Vander, for accepting this challenge. I would just, as I explained it to you earlier. So I'm going to do some brief introduction, and I think in like 9 minutes we can start with your talk. Okay. So for the introduction, I just want to go for the housekeeping again, as Alexandre mentioned last week. I'm going to do some housekeeping announcements again, and next Vander is going to do his presentation, and we're going to have some final thoughts and after his presentation. Okay, so regarding the housekeeping announcements, we're going to still use English as main communication language. I saw some people exchanging messages on WhatsApp in Portuguese. Please, you can do it, but I think that's a great opportunity again to use English as our main communication language, so you can improve, you can use it. We have Google Translator for those who are not used to write in English. Even though I think that's it's a key aspect for those who are pursuing the PhD and even the masters. So I think that you should do it. We should keep this in mind when you're doing our conversation and also exchanging ideas on WhatsApp. We're going to be using Google Meet, as you can see, so it's working pretty well. So Alexandre has been doing a really good work with editing the videos, so it's really good. And I think that Google Meet is still a very good tool for doing this. We're going to do audio recording and including this video on LacaiStube. I think, if I'm not wrong, we already have our second seminar.
I'm already there.
Okay, perfect. So we're gonna we already have this video on LacaiStube for those who are not didn't make for the last seminar. So for those who didn't make and want to still watch the video, you can Google LacaiStube, and it's going to be the second seminar. So for the first and the second seminar, we try to keep this close. So we invited a few people, a few external people, let's say, to take part in the seminar. But now I think that we're improving, expanding a little bit more our invitation. So I even publish it on LinkedIn and also Twitter. So I think that this is going to be a very good opportunity to be in touch with different people. Let's see. And feel free to invite your friends as well. So for those who are taking lecture, assuming this is a lecture for the master's or PhD program, you can also invite your colleagues who might be interested in the topic that's going to be discussed on the day or next week or the week after, or whatever. So just invite your friends. Feel free to invite your friends. Okay. So just for those who are pursuing the postgraduate units, so you still have to read the papers who are assigned for you, and also the suggested video. I think Alexandre published the video like for the last week seminar. This week we didn't have the video, but just keep in mind that we might make available some videos that you have to watch before.
Whatever material is there next to the topic that we'll be discussing in the week. It's usually at least one paper. Sometimes it's two papers. Sometimes there's one or more videos.
Yes, exactly. So, and finally, I think that this is for those who are in the third seminar. I think this is usual. So you just have to register your attendance on the following link. So this is going to be good for us to track the attendance and also track the people who is in the seminars, who's in the call, in the video, and then you can just try to understand the behavior of people. And it's going to be good also for those who wants to get a certificate as isolated event. And this is going to be important if you do it. This is important that you do it, so we can just mailing the certificates for the emails that you register on the link. Okay. So next, I just shared the YouTube. You just have to Google Lacai's Tube on the YouTube, and you're going to see not only the videos that we have there from the seminars, but we also have some different videos from ISLA conference that Lacai is dealing with for a long time. It's going to be really good.
As we didn't update this from last week, it's already slightly different because we already have last week's presentation also there.
Yeah, perfect. That's good. Exactly. We're going to have the second video here on the list, on the playlist, so in the playlist. But feel free to watch the other videos, and it's going to be it's very good, the content that we have there. Okay. So for the schedule, we are going for the third seminar, and then it's going to be about mobility. Just to keep in mind that we have this. We're going forward on the seminar, also on the lectures, and it's going to be very good. Okay, so the fourth announcement is going to be about Moodle. So we're still using Moodle as our main platform, virtual platform for centralizing the videos, some announcements, and also some texts. So, and also the papers, of course. So you just have to use this link to access the Moodle platform. And finally, last but not least, we have the WhatsApp group. For those who are not engaged on the WhatsApp, you just have to click here, and you're gonna be updated with the last news that we have from the seminars. But also, it's gonna be really good to have some discussions on the WhatsApp group. We have a lot of discussions over there, so it's really good. Last week was not that much, but I think that it's going to improve a little bit in the next weeks. So it's a very good opportunity to be in touch with different people as well. And so I'm just inviting you to access the WhatsApp group as well. Okay, so regarding the assessments, again, we have two types of assessments for those who are pursuing the postgraduate units and the teaching units. As we mentioned in the slides, we have a pre-summary, which is a 200 words abstract you have to submit on the Moodle. And also after this presentation, we're gonna have the post summary, which is the same format, 200 words abstract, but with a different, with a slightly different, which is the question that we made on this post summary abstract. Okay, just pay attention to the questions, because some people are answering different questions on the summary, and it's really good if you follow the question that we did and that we put on the abstracts. Okay, so finally, so next, I would like to invite Vander for making his presentation. So I think that we have some. Okay. So I think I would like to invite Vander for making his presentation. And once again, I would like to thank you, Vander, for accepting the challenge and make your time to be here and give this presentation. I think with 2 hours difference, just to have 2 hours to be prepared is a very short time, but I'm pretty sure that you're going to do a very good presentation. Okay, so I'm going to stop sharing my screen. And perfect. Thank you very much, Vander, again, and the floor is yours.
Okay, so thank you very much, Flavio, for the invitation. And well, my name is Vander Freitas. I'm from at Federal University of Ribeirao Preto. The work I will present here today is a work I've done in collaboration with Thais Constantiner, which is a professor at the at the Preventive Medicine Department at UniFesp, Jefferson Mendes, which is a undergraduate student at UNESP, Katia Sepetauskas from Semaden, and Leonardo Santos from Semaden as well. And well, I had only 2 hours to prepare my presentation, so I apologize in advance if there's something wrong here with the slides, especially if there's something in Portuguese, but I'll do my best to present to you. And it's a pity that you don't have Professor Leonardo Santos here today, because he is a much more specialist on mobility and epidemiology than I am. But okay, let's do it. So the title of the work is The Correspondence Between the Structure of the Terrestrial Mobility Network and the Spreading of COVID-19 in Brazil. The idea of this work actually was to understand how the mobility network, actually in special the terrestrial mobility network, relates to the spreading of COVID-19 in Brazil. So we have the data of the flow of people between pairs of cities in Brazil in a ordinary week. And we have also the data of COVID-19 with the date in which the notifications each city have done when the first case appears. So we have the first notification at the city of Sao Paulo, then the second in Barra Mansa, and so on and so forth. So we have this ordering, these cases of COVID, the cities that notified COVID sorted in some way according to the date. If you have any questions, so should you have any questions during my presentations, please interrupt me. I will be happy to try to answer you. So the presentation today is basically an introduction. I will talk about the data we have used. I will present you some results, the conclusions and perspectives, and some references. And a first disclaimer, I'm not an epidemiologist, but Dr. Thais Constantiner is. And this helped us a lot to keep our feet on the ground. So when we from computer science, we start to deal with data, we can have lots of results, and sometimes those results are not connected to reality. So we have to have some help from people that understand the phenomena which is being studied. And this is why we invited Dr. Thais Constantiner to be part of the project. Okay, so the idea behind networks started with the graph theory. I think all of you already know the story. So Dr. Euler on 1736 started to work with this problem of the 7 bridges of Königsberg. He would like to trace a path here, crossing all bridges only once without making repetitions. And he realized this problem was not possible, but back in the day, they didn't have the mathematical framework, the mathematical methods to analyze such problem. And he came up with this idea of the graph. And the graph we use today comes from this time here. So a graph is actually a set of nodes, vertices, and edges that connect those vertices. So here in this example, we have here 1, 2, 3, 4 islands, which are represented by those nodes here, and the connections between them represents the bridges. So we have here from this island, which is the same as this one, represented by this node, and those 3 bridges are represented by those 3 edges here. So by analyzing a mathematical formulation for this problem, the problem became a little bit easier to solve, and Euler came up with some conclusions that it was not possible to cross all the bridges only once. Okay, so we have the graphs, and when we represent some complex systems using those graphs, we have the so-called complex networks. So by complex system, we mean those systems that are composed by many parts that somehow interact with each other, and when we try to analyze each of those parts individually, we cannot have so much information about the system, so we have to see them globally. We have to somehow understand the connections between them, and somehow the system is a bit more than the simply sum of the parts. Okay, so when we represent the complex networks using graphs, we have when we represent the complex systems with the graphs, we have the complex networks. And the idea of using complex networks gained a lot of attention in the late 90s and beginning of the 21st century. And as you can see here, in this graph, we have here in this axis the years from 1960 to 2010. And here in this other axis, we have the number of citations those papers have received during the years. So we have here those 2 papers related to networks, network science and complex networks. And we see that they have received a lot of attention on the end of the 90s here. But why did this happen actually? Well, partially because of the emergence of the network maps. Because back in the day, there are lots of people dealing with networks, but each of them was somehow working in separate. So people from neuroscience was trying to understand how the brain connections were formed and how the synapses would occur on those connections. People from engineering side was dealing with transport networks, and people from computer science was dealing with computer networks and lots of topologies of those networks. But somehow, all of those networks have some things in common. If you try to understand the topology that they use, we can come up with some measures, with some understanding of those networks, and somehow there is a lot of overlapping between them. And the emergence of network maps, as I show here in this slide, you can see that in 1998, someone started to build this movie actor network, which consists of nodes that represents actors, and they are connected if they acted in the same movie. Okay, we can also build the network of the World Wide Web. If we get every single website and make a connection between this website and every link it has to other websites, we can build a huge network of all the websites we have in the www. And lots of other networks. And when people started to share those works and analyze them as a set, them all at once, they have realized they have lots of things in common. So this is when they understood the universality of network characteristics. So the architecture of node networks emerging in various domains of science, nature, and technology are more similar to each other than one would have expected. As you can see here in this picture, we have here a computer network in which each node of the network, each vertex is a computer, and they are connected somehow using cables or wireless connections, let's say. And here we have the actor network. So Marlon Brando is connected to Al Pacino because they have acted in The Godfather, in Portuguese, O Poderoso Chefão. Al Pacino with Michelle Pfeiffer in Scarface. So, and here we have the interactions between proteins. And as you can see, those three networks, although they are very different in their meaning and application, they can be represented with this structure here. And also I invite you all to watch this movie here from the 150 Years of Nature, the journal. They present here a astonishing video about how their papers connect to each other, which papers cite each other, and how some very important papers originated whole areas of science. It's impressive, this video. Please watch it. Okay, so now that we have understood that some of those systems can be represented as networks, so now let's try to understand a little bit more about the network measures we have. This, for example, degree. What's the degree of a node? Well, degree of a node is the number of nodes that it's connected to. So in this case, the degree of A here in this network is 2 because it has 2 connections, right? Well, to compute the degree, we do not consider the weights here. So let's consider all those numbers equals 1. So degree of A is 2, degree of B is 4 because it has 4 connections, degree of C is 2, and so forth. The strength of a node, on the other hand, considers those weights. So in the case of node A, the strength of A is the sum of the 2 weights that reaches A. So in this case, the strength of A is 7 plus 5, which is 12 here. And the strength of B is 7 plus 8 plus 7 plus 9, which is 31. So we can compute the weights, the strength of every single node in the network. So as you have realized here, both degree and strength, they only depend on local information, right? They only see those connections that reach them. But on the other hand, the between centrality is a bit different because it depends pretty much on the whole network topology. But before I start to speak about betweenies, I will tell you about shortest paths. What's a path in a network? Well, if you want to go from node A to node G, for example, and again, do not consider the weights, okay? Let's say that all those numbers here are equals 1. So what's the path between A and G? The path between A and G can be done A, B, E, G, or A, B, C, E, G, or A, D, F, G. There are lots of paths between those 2 nodes. But which of them are the shortest path? Well, the shortest paths here in this case, I'll tell you, is from A to G is A, B, E, G, or A, D, F, G, or A, D, E, G. All of them have length equals 3, right? So they have length 3. What's the shortest path between C and G? Well, it's C, E, G, which has length 2. And there's no other path that is shorter than this one. So now that we know the notion of shortest paths between any pairs of nodes in the network, the between centrality is not complicated. It's actually the rate of those shortest paths that pass through a node. So let's say here, node E. How can we compute the betweenies of node E? Well, we see here in this network all possible shortest paths that exist in the network and compute how many of them that pass through E. So when we compute here, this first term is the number of shortest paths that pass through I, sorry. In this case, we are seeing the node E, divided by all possible shortest paths. So when we compute this, we have the between centrality. So although we can have the between centrality for each node here, it no longer depends only on local information. It depends on the whole graph, on the whole network. So here, the between centrality of node A is 0 because if you consider all shortest paths here that do not start at A or end at A, there's no shortest path that passes through A. So this is why it's 0. On the other hand, when we see the node E, it's very important because it connects lots of parts of this network here. So this is why it has the higher value here of between centrality. Okay, and what's the diameter of the network? The diameter of the network is the length of the highest shortest path. So we compute all the shortest path. Which one is the highest? So this highest shortest path is the diameter of the network. So this is a measure of the entire network. It's not of a node. And lastly, I will present you the concept of vulnerability of a node. The vulnerability, it quantifies how vulnerable the network gets when node K is removed. Okay, let's do it in parts. What is EIJ? EIJ is the efficiency between nodes I and J. But what is the efficiency? There are some ways to compute efficiency, but the standard way is to use the inverse of the shortest path. So what's the shortest path between node I and J? We compute the shortest path and compute the inverse. The inverse is the efficiency. Okay, so in this case, what's the efficiency between A and J? It's 1/3, right? Because the shortest path is 3. Okay, when we compute this summation here and divide by the total possible number of edges this network could have, we have the efficiency for the entire network. So as soon as we have the efficiency for the entire network, what we do is the following. We pick a node, node K, and we just remove this node from the network and compute the efficiency again in the absence of this node. So if we remove here node A, of course, those 2 edges will go out as well, right? So all we will have, let me try to write here. All what we will have remaining is this part here. So we compute this efficiency here, and we will have EK, which is the efficiency of this network in the absence of node K. And when we compute the difference between the efficiency of the original network minus this efficiency of the network without the node K, we have this vulnerability. So in other words, this is not the vulnerability of the node, it's the vulnerability of the network in absence of this node. Okay? So here again, as you see, if we remove node A, look how many connections it has, and it is important because of the shortest paths as well. So when we remove it, the network is quite vulnerable, right? Okay. Now I'll talk about the data we have been used. Okay, we have used this mobility network data from the Brazilian Institute of Geography and Statistics, IBGE. What is this data about? We have the flow of people between cities in an ordinary week. What does it mean? They have measured how many people goes from one city to another. It doesn't matter if those cities, they have borders to each other or not, okay? So you can compute, let's say, the flow of people from the city of Sao Paulo and the city of Aracaju, okay? And they have this flow of people during a ordinary week. And this data is from 2016. And here, this data has some limitations, and I will mention some. One of them is we don't have the complete flow of people, actually. We have the flow of people from one bus station to another, because this is the way they found back in time to track how many people, not cars. Yes, Gabriel, not cars, only from bus. Because they try to track the tickets that were sold in a week, considering all companies that sells those tickets to passengers, and they have this flow of people from buses. But of course, they do not have only the terrestrial flow. They have also the flow using the rivers. Okay, so here in this data, someone asked about the airplanes, not airplanes as well. Only terrestrial by bus or by boat, nothing else, okay? Yes, the boats are important for the north of Brazil, and that's why we haven't considered the north of Brazil in this analysis, okay? Because we would like to use only the terrestrial flow, because this flow of people through boats actually started to be very important at some point of the pandemic, and when we started to analyze the data, it was not that important at that time, and then we realized not to include it, so not to mess the network we had, okay? Okay, so here in this work, we only use the terrestrial flow, so people traveling by bus. And the other data we have used is data about COVID-19, of course. We got this data from this website, which is maintained by Wesley Cota, which is a PhD student at Federal University of Viçosa. at the very beginning of the pandemic, he started to scrap some information from the Brazilian Health Ministry website and some local health offices as well, and grabbed them all in a single portal. So we could download those data already formatted and available in CSV format. So it was very convenient for us. And as I have seen, lots of paper came using the very same data. Okay. Okay, so what did we have to do here in this work? This is our question. Which measures of the terrestrial mobility network better match the emergence of COVID-19 in Brazil? In other words, is our terrestrial mobility network somehow a proxy of how the transmission occurred in the country? This is what we try to solve, to answer. Sorry. And well, we started to work with this data and to build networks, to compute measures, to see the data of COVID, to compare the measures, and to compute the robustness of the network, and lots of strategies here. Sorry, this question is about to move. I believe it's better if somebody says the question for me, because sometimes I cannot follow. Okay. Okay, so we have prepared those two preprints. This first one, we have done a robustness analysis in the mobility networks, but without the COVID data yet. And then the second one, we have done what I will present today, actually. And actually, the second one was published last week in the Reports in Public Health, with a journal of Fiocruz. Okay, about the data. In our data, every single city is a node in the network, and the edges that connect those nodes correspond to the flow of people. So just a disclaimer here before I continue. Some people usually confuses mobility network with transportation network. Transportation network is more physical. So if we have, let's say, two cities and they are connected somehow by some highways or some roads, this is the transportation network. But the mobility is a process. If there's no people coming from city A to city B, there's no node, there's no edge between those cities, okay? So in this case, it doesn't matter the physical aspect of the network if there is some highway that connects the cities. Here, we're considering the mobility of people, so the flow of people. From this data, we built two networks. The first one is the cities of Brazil, without the north region, because of the reasons I have already mentioned at the beginning, as we didn't have access to some interesting aerial network, and also because the cities from the north region started to become, the pandemic there started to become a little bit complicated a couple of months after the beginning of the pandemic. We decided to drop this region and just analyze the rest of the network. Okay, so this is our way to try to do things more responsibly, because otherwise people would criticize our paper, of course, because of the problems I've mentioned. Okay, this first network has almost 5,000 nodes, and the second one 620. And the first network for the Brazilian cities without the north region, we have almost 60,000 edges, and the second 4,796. And okay, but we have realized something as well. In our first very early analysis, we have seen that some nodes, some connections between nodes were not so important because the flow of people was too small there. And then we were trying to come up with some threshold in which we could restrict only the connections between nodes with some minimum value of flow of people. So those connections whose flow of people was smaller than a certain eta, they were removed from the network. Okay? So what we have done to find some proper eta to analyze, we have varied this value of eta, and then for every eta we had, we would compute the diameter of the network. So at the very early, for eta equals 0, for example, this eta naught here, for eta naught, the diameter of the network is smaller than 10. So this is our original network. So as we start to increase eta, we see that the diameter of the network increases as well, because we remove some shortcuts between cities, and these shortest paths start to increase as well, so the diameter. And then after a certain point, this diameter of the network starts to decrease, because the network here starts to lose lots of nodes. And we are interested exactly in this point, where the diameter starts to decrease. So we have here two thresholds, the eta naught, which is eta equals 0, our original network, and what we call eta d, which is our eta after we analyze the diameter. Okay, so this is the graph for the Brazilian network, and this is the graph for the São Paulo state network. So we have here eta d equals to 200 and something, and here equals to 160 approximately for São Paulo. So if I go back this slide, the original network for the Brazilian cities has almost 60,000 edges, and here we come up with 2,000 only after we apply that threshold. For São Paulo, the same. After we apply the threshold, it's almost 10% of the original.
I have a question about a doubt that I had when I was reading the paper. Can I ask now, or should I ask later?
Sure. No.
Okay, can you go to the previous slide, please? Okay, so in the Brazilian without mark network, we can see that in the eta G network, the average degree is 1, right? And
yeah.
It was hard for me to figure out what this means, because it would mean that the network is composed by a lot of pitches, a lot of paths with 2 nodes only, or there are a lot of vertices that are not connected to anything. I mean, is there some explanation for this average degree of 1 that's intuitive?
Actually, it's because most of the edges are not there, as I have said, and I'll show you this picture here. This is how our network looks like after we remove all of those edges that are smaller than a certain flow. And as you can see here, only the very connected cities have some flows, the others not. And probably this value came here because we are probably computing the average degree, considering also those nodes that don't have any connection.
Okay, that makes sense. Thanks.
Yes. I'm not sure, but yeah, I think there's no other explanation for that. Otherwise, you would have lots of pairs of nodes connected, right?
Yeah, I mean, the average can only be 1 if there are vertices with degree 0. So it makes sense.
Yes. That's it. Okay, so as you can see here, there are lots of cities, important cities here because they are very well connected. When we use the eta d, okay, I'm not plotting here the eta naught as well, because eta naught has almost 60,000 edges, and you cannot grab any information when you plot them all. Okay, so here also I call your attention for the city here, Feira de Santana in Bahia, state of Bahia. Although it's not the capital of the state, it's also very well connected. Okay, so this is for Sao Paulo. Those light violet edges correspond to the eta naught, and those that are red here correspond to the eta d. So you have some cities here that play very important roles. And here we present those measures for networks considering a geographical representation. So here we have the measure strength, which is this S, with eta naught. And when we have strength with eta naught, we can see which of the cities are more important considering the strength, the flow of people that reach them. And the redder they are, the higher their strength, okay? And when we apply now eta d for the same network, we see that some important cities start to be not as important as before, because some of them actually lose completely their strength because they don't have some edges that reach them. For São Paulo, the same thing. We have here S with eta naught. São Paulo, of course, is very important, very well connected. And here is for eta d with less edges. Okay, so now we have the measures related to the network, and we have the COVID data, and how do we relate them? Okay, we have built this table here, in which the first column of the table, we have here the cities that notified COVID-19 before the others. They are sorted here actually by date. So São Paulo notified first, Barra Mansa notified second, then Feira de Santana, Rio de Janeiro, and well, as you can see here. And when we compare this column here, considering the COVID-19 data, and the networks we have computed from the the measures we have computed from the networks ordered from the higher value to the smaller. And here, of course, I only listed 20, but you can have an idea of what's happening here. So we have here for the Brazilian network, the strength with eta naught ordered from the bigger value to the smaller, and we have some correspondence. I have colored some of those cities accordingly here, so we can check them in all columns here. We have here strength, here degree, here betweenness. So we see that the network measures somehow capture how the the disease is spreading, right? Yes, and also when we were analyzing this data, of course, we had a lot of questions, of issues to solve, because firstly, we are not sure that the data we have is perfect, and of course it's not, because in Brazil we're not having enough tests since the beginning of the pandemic, so we don't know exactly how the disease is spreading through the country, but we have an approximation, which is this data here. And we would like to see if our network measures could approximate to the approximation. So you see that this problem is not very easy to solve, right? Because our, quoting, ground truth is not very true, right? Okay, so we have here also the results for Sao Paulo state. We have here this first column, the cities of Sao Paulo that notified COVID, in the order they notified, sorted by date as well. And here the network measures. This is for eta D, and eta naught. So you see that there are some correspondences. Sao Paulo, of course, is the more important node, regardless the measure we use, because it receives most people, and also it's very well connected, and so is Campinas, and so is Ribeirao Preto, and other cities. Okay, but one question, sorry. Let's see the questions. Okay, I have a question. Why do you order the cities by how early the first case appeared? Why not use the average growth of cases per capita or something like that? Well, I ordered the cities according to the first case appeared because this is the best approximation we have, I think. Yeah, because the only data we have is when a city notifies a case, this case is notified in some data set, and we have access to that. But we could also, of course, order the cities by the first city that reached, let's say, 100 cases, or that reached 1,000 cases or something like that. But I'm not sure if this is exactly how we can measure the importance of the city. So we decided to order this regarding the first day they notify. Do you wonder why some results, for instance, Santander? I have no idea. I have no idea, actually. This is the data we have. This is the network. And as you see here, if we compute the between centrality using the eta naught, Santander appears in the first 20. So yeah, Santander is somehow important for the network regarding connectivity and transitivity. Okay, so how do we compare those columns here with the first one? What we have tried is the following. We got the first, let's say the first register here is Sao Paulo. Then we compare with strength for eta D. And we see that the correspondence is 100%, right? If you compare 1 to 1. Okay. But what happens if we get the two first appearances here, Sao Paulo and Santana do Parnaíba, and compare with this column? Well, we see that we have a matching of 50% because we only got Sao Paulo. And if we get the three first, then we have 1/3 because we only have one correct. And then we have tried for an increasing number of cities, okay? So we started with 1 and increased this until the last case of notified, until the last notified case of COVID. So let's see here. Yeah, we have analyzed the data until June 4th, okay? So we have here, so let's see first this part of the graph. So here in this axis, we have N, and N is the number of cities I am comparing here. So I start to compare from the first, then those 2, those 3, those 4, and start to increase N. So the set of cities I'm comparing with the matrix. And I see that when I compare the first, of course, I will have 100% because Sao Paulo is the first in all metrics. But then when I start to increase N and get a bigger set here, I see that in the beginning of the pandemic, I have this wiggling pattern here, those oscillations. And it also happens for the Sao Paulo state network. So I have those oscillations in the beginning, and then somehow they kind of start to be steady somehow. And then I see that at the beginning, I start to have a P, which is the rate of cities that I get right. I have a matching here from the first column to the others. I see that they are somehow around 30% here. And then they start to increase. And of course, whenever all the cities have confirmed cases at the end, I will have 100% because I will have the entire set, okay? So one question we had was the following. Okay, I am having a matching around 30%, but is this better than if I get the cities by chance? In other words, let's say I have 10 I have n equals 10. So I have this entire set here from Sao Paulo to Campinas, all those cities. If I have my entire set of cities, which is 4,900 something, and I get 10 cities by chance, how much do I have? What's my matching? What's my matching? Well, I have seen here that in the beginning, it is quite small, right? And here, this gray region, it accounts for the average of the matchings I have gotten after 100,000 runs. And then I have plus 2 standard deviations and minus 2 standard deviations. So this is what this part here represents, this gray region. And we see that the network metrics have better matchings than taking nodes by chance. So they are somehow a better heuristic of the COVID-19 spreading than choosing cities by chance, of course. Okay.
Vander,
yes.
I have a question here. No, I was just thinking, of course, for this pandemic, we did probably most of what we did wrong. And it's much easier to predict the past than the future. So now we all have the solutions for what we should have done before.
Yeah.
But maybe we could say that what your results show is that if we have another pandemic, or if we have a situation like this, and we go for these hubs, the cities that represent the nodes, and we focus on them, we will reduce the problem pretty much. Is that what you claim that would happen? And we should focus on these cities?
That's it, yes. Because, well, how does a disease come to a country? Probably by plane first, and then they start to spread through the whole country by terrestrial flows and by boats and so forth. And okay, but which cities will be hit first? This is pretty much what we were trying to say. If you take a look at those lists here, they are basically the cities that have higher probability to be hit first.
Yeah.
Due to their connectivity.
First, the cities that had connections with Italy or wherever the people were coming back from in January, right? So that's probably why it all started in Sao Paulo and some of the cities in the Northeast. I don't know, but as you said, first the plane, and then right after, transportation or terrestrial transportation. Yeah.
Yes, exactly. This is what we expect, at least, and this is what other papers say as well. And actually, there is one future work we were trying to design, which is the following. We have now the airplane mobility network, we have the terrestrial mobility network, and we have the network mobility using boats. When exactly each of those networks had a play actually important in this COVID-19 pandemic. So we expect, of course, the aerial network to be important at the beginning, and then the terrestrial, and a little bit after the connection by boats, but we don't know exactly when they started to be very important in relation to the others. So this is something we are going to try to do in the near future. Okay.
And then something that people claim is that, of course, cities that have subway were cities that were more affected than others, because again, it's mobility, but then mobility within the city.
Yes.
And that's probably something that you could try and map as well, because I mean, during the pandemic, everyone was saying what they wanted without data. Now we have data, and maybe we have time to analyze this data, at least so that we know what to do the next time.
Yes, exactly. And also those kind of data, they are actually now available for many cities. If you want to see what happens inside of each city in another resolution, of course, because here we are seeing the connections between cities, but what does happen inside each of those cities? And we have those origin destination data for Sao Paulo, we have for São José dos Campos, we have for lots of those big cities. So we know more or less from where people come, where they live and where they work, and how much time they take from home to work or to study or something, some activities related to that. So if we have those data for each city, and if the person is going by car, by bus, by subway, or any other transportation, it's important as well, of course. And actually, I have a student, an undergraduate student, that is now trying to see the aerial network, and another that is looking into the data from the city of Sao Paulo in different modes of transport, like subway, cars and bus, and so on.
Vander, remember this study, I think it's from Leonardo and you as well, in São José dos Campos, in which I think it was a person from a specific neighborhood in São José dos Campos, and the guy was claiming that COVID-19 was not there. So it was the only neighborhood without COVID-19 since that study. And Leonardo was, no, according to the analysis that we did, you actually have at least one case of COVID-19 in the neighborhood. And the guy was saying that not, we don't have cases here. And I think after sometimes the guy tried to start to interview and start to talk with people from the neighborhood, and they actually found 3 or 2 cases of COVID-19. It was a very interesting case to understand the behavior of the mobility of the virus within the city.
Alexandre, I cannot hear you.
Yeah.
Yeah, Jose Antonio has a question there in the chat that maybe Vander could address.
Okay. For Sao Paulo, there's a high concentration of COVID-19 data in cities of the metropolitan region. Do you thought to treat them together? Well, actually, this is something we would like to do actually as well, but with the time we had, and actually this work we have performed it in the very beginning of the pandemic, and we didn't have enough feeling of what was going on actually, and we treated the cities separately, as I have shown. But of course, we can do this considering the regions. If you see here this plot, oh, sorry, not this plot. I think the new plot from the publication, I can show you in 1 second. Just 1 second. It's here. We didn't treat them together, but we know that we have to do this. So we have, as you see here, split the regions according to their micro regions here. So this is the next step as well, to consider them not the cities disconnected from each other, but the regions. This is another resolution to treat the data. So you can analyze this data in several resolutions, as I have said, considering the entire country, city by city, or separating the states, or separating the regions, or inside a city, the neighborhoods, or the roads, or, there are lots of resolutions to deal with this problem. And currently we are lacking personnel. So it's both Leonardo and I have a lot of work to do, and that would be nice if somebody could get interested to do that with us, and of course some collaboration may appear from that. Okay, let's go back to the slides. Okay, so as you have seen here in this graph, the correspondence was not so good here in the beginning, but it was better than taking by chance. But after some while, some measures started to cross this taking by chance line here. So they started to be meaningless, as you can see. It's because the more cities you have with confirmed cases of COVID, of course, the more you approach from the total set of cities we have, and it doesn't matter if you have a measure or if you take by chance, they will all somehow converge to 100% in the end, right? And okay, if you see Sao Paulo state here, which is the second graph, we also have this wiggling pattern in the beginning. Of course, it's because in the beginning of this spreading process, it was not very well defined where the disease would go. But after some while, considering the patterns of contacts between people and how each city handles the disease, it was a bit clear after some while, and our measures started to get it better correspondences. And if you see here, this S with eta D, which is this line here, it starts to be good here at the beginning, right? So it means that if we get the networks without the small level flows, it is a better proxy to the disease spreading. But after some point here, at the end of April, beginning of May, this measure here started to be the best one. So strength with eta naught, which means that the original network started to be a better approximation. What does this result tell to us? Probably this is the interiorization process of the disease. It started to go to the countryside of the country, of the state, I'm sorry. So in the beginning, only the big cities had cases, and after some while, the small cities as well. So we had to consider the flows, the small flows as well, right? So this is what this transition means. So at least it's what we expect this mean. Okay, and we got every single of those lines here and computed the integral behind them, below them, just to see in average which of them was better than the other, considering the correspondences for the entire set of n. And we saw that, so this here, in this axis, we have the thresholds. So here we're not considering only eta naught and eta d, but we are seeing other intervals of eta as well. of thresholds. So for the Brazilian network, we see that eta d is not very good, right? Because this R here is the integral, okay? So the higher the value, the better is the matching between the network measure and the COVID data. So in this case, S with eta naught is better for Brazil, considering, of course, eta naught and not eta d, as you see here. But for Sao Paulo, we see that both eta naught and eta d are good, right? They have good correspondences considering the S measure. So in this case, as I have shown here, eta d is better in the beginning, then there's a transition to eta naught, and those are the matchings we have. So
I wonder, what do you think that would explain these differences in patterns of the state of Sao Paulo graph and the one for the whole Brazil?
Yeah, this is something we have discussed in the beginning, and actually it's still not clear yet what is happening, because I would expect, at least also in this network here, that eta d would be nice in the beginning, and then there will be somewhere a transition to eta naught, the same as happened in Sao Paulo, but it was actually not the case, as you can see here. At the beginning it was a bit fuzzy, but we see that S with eta naught is the best to the end, right? At least until June 4th, of course. And I don't know the explanation, but that's how things happened. And some discussions here, we see that, as I have said, S with eta naught performs better in the Brazilian network without north region, and S with eta d performs better in Sao Paulo in the beginning, but then there is a transition to eta naught. And most measures we have tested here, they are statistically significant in comparison with taking by chance, right? And some countryside cities, such as Campina Grande in Paraíba State, Feira de Santana in Bahia, and Caruaru in Pernambuco, they have higher S, which means they receive higher flows of people than some state capitals. It means that they are very well connected and receive a lot of people. So they are very likely to receive cases first than the other cities of the same state, okay? And well, I have seen that Feira de Santana, for example, it has a very big bus station that connects the state of Bahia with some other states, and also the countryside of the state with the capital. So it's very important. So this is at least one of the cities I can explain why it's so connected. Okay, so this is all I could prepare, those 2 hours Flavio gave me. So I hope you have enjoyed, and I'm happy to answer your questions if you have some. Thank you very much.
Wonder, while people are thinking of their questions there, just have a look at what Gabriel wrote there. Gabriel is a researcher in Uruguay, and he's just trying to contact you with some researchers there that apparently have done some similar work. And maybe you could.
Yes. Do you have more questions?
I think we do have one question from, I think it's from Luis Cesar about the measures.
Mm-hmm.
Did you measure the proportion of mobility by bus, comparing with total mobility like cars, planes, and boats?
No, we haven't. First, because the data we have, I'm not really sure if there is a data that we can trust about the amount of people that use cars and go from one city to another, covering the whole country. But, well, if there is such a data, please let me know. And this is why we used actually the data from the bus stations, because this is, I would say, we can trust them, because the companies, they sell tickets, and IBGE have done a very interesting work collecting all this data together. And the aerial data as well, although we have this data already, I haven't checked it, but we could see the proportion for sure. Yes, thank you.
Interesting. Yeah, while people are still thinking of questions there, one thing that I think that is very important for these seminars of ours, as we're talking about information systems, this is specifically an information systems work, because it deals with using computing to work on some theory that had been in sociology for 40 years or so, maybe more than that, network analysis. We always think that it started when we started developing software for that, but sociologists have been done that at least since the 60s, and I think there are a few papers from the 40s or 50s or so.
Yes, before that, actually.
Yeah, even before that. So what we're doing here is we have a problem that is a problem, well, in this case, not exactly a problem of an organization or organizations. So we are already broadening the scope of information systems, not only to consider problems of organizations, but also problems of our society, right? And we're figuring out of using computing and information systems in order to better understand those problems and provide an answer to them that was impossible without the use of the technology that we have available, right? Okay,
Yeah.
Pablo has some comment there or a question. If you want to open your mics, people, please don't be shy. You were less shy today.
About Pablo's question, of course, there are some ongoing works on checking about the possibility of dealing with future disasters, considering other kinds of disasters, of course. And actually, Leonardo Santos is the specialist on that, since he works at the CEMADEM, which is a national institute that deals with disasters. And this is why we started to work with COVID-19 data, actually, because he had this background and, well, I know something about network science, and we started to work together. Okay, about next steps. Well, next steps, as I said, we would like to see how it works in different resolutions as well. There's a student of mine working with data from the city of Sao Paulo specifically, checking how the COVID-19 is behaving in the city. So considering the mobility of people from point A to point B, so let's say from their homes to their workplace or to their gym or other activities. I'm not sure yet whether we have very specific and detailed data, but what I can tell is that we have at least the mobility from neighborhood to neighborhood.
And one interesting thing that happened in this situation that we are living, and in a moment that we are polarized, I mean, everyone has their opinion, and they try to force their opinion on others, but we have to use this data. I mean, there's a lot of data there to be, dealt with and treated in a way that we do not have to depend on people's opinions, right? Of course, opinions may motivate our research. Opinions may be, if we have some doubt about something, and even if we have something that we believe to be a truth, but we want to prove, that already opens or paves the way for us to do some interesting research. So one thing that has been discussed a lot, but mainly based on opinions, is the fact that the public transportation means used in our large cities is one of the main means of transmitting the virus. It seems obvious that if you have people packed in an environment, that helps that to happen. But let's check it, please. Let's check all these things. It's a crazy virus that nobody understands well. We get data from all different places, and I don't know if you have the same impression that I have, that we cannot make sense of it because different data point in different directions. But it's only after we have analyzed all this data that we'll get to more reasonable, more rational, at least material that could help better decision making even by our leaders, if they ever consider using that reasonable information instead of just their opinions, right?
Yes, and actually in science, usually when you have a statement, you try to say that your statement is not false instead of trying to prove it's true. So in the case of trying to make your statement true, you try to prove it's not false. So in that direction, you have to analyze a lot of data just to make sure that you cannot make it false.
Mm-hmm. Yeah. Mm-hmm.
So people, they only have an opinion and try to say that it's scientific, but you have actually first try to say that what you're saying is not false, and it takes a lot of work and a lot of research.
And the main reason, Vander, for us to do research like that we try to falsify something or a statement, and then we say, well, with the data that we have, we cannot prove this false. It means that for now, we will take it as an acceptable explanation of reality. But at the same time, we do not turn it into a dogma that becomes like religion, something that we cannot step away from in the future when we have more evidence that makes us think differently, right? So I think there is still some light in the universe. Whoever is trying to do science is trying to shed some light into problems. Of course, we all have our opinions, and we all have to be very conscious of the fact that and that's another problem that we techie people brought to the world with these electronic social networks make us only talk to people that think the same way we do, and then we believe that our opinions are religious truth, and we don't debate them any longer, at least the way we should. Jose Antonio is saying something there. It seems that he still has a question there. The method is fine and it can be improved using other models of transportation or dealing with microregions. But a question about the source of data, the fact that, oh, had you already answered that one? Sorry.
No.
No?
No,
Okay.
I haven't.
Okay. So the fact that it was or it is not officially and public, do you think it can harm the results?
Well, I think you are all following the news, and the data we have about COVID-19 in Brazil is a bit poor. We don't know exactly what is happening. What we have is an approximation. And actually, if you go to the Brazilian Health Ministry website, you will see that the data is pretty similar to what Wesley Cota, which is the source I have used, is delivering. So I would say, although the data I'm using is not official, is not from the government, it is very similar, and the numbers are quite the same.
And besides, and unfortunately, Vander, sometimes nowadays we have to challenge official data, because it has been the time that we trusted official data blindly, right? Nowadays we have to cross it with other data, because
Exactly.
always some other interests, some vested interests there that have to be taken into account. It seems that there's a lot being said there in the chat now. Pablo, I think that it can be more interesting. For example, companies can be using the similar approach to calculate motion of people and to adjust supermarket stores, products, etc. When you're using something like that, can be usual to understand the flow of people and adjust stores and supermarkets to its in this pandemic. Some people to decide to move for country cities after pandemic, working remotely. What do you think of this approach?
Yes, of course. I think this is feasible, but the problem of always is, do we have data to do that? I'm not sure. I know that actually the IFT, Instituto de, I'm sorry, I don't remember the name. There is an Institute of Technology in Sao Paulo. What's the name? Sorry.
In São Paulo?
Yes. Yes, IPT. Yes, IPT, Instituto de Pesquisa Tecnológica.
Yes.
That's it. Yeah, I'm pretty sure they are working on something related to the flow of people using cars as well. And the data they have is updated. They were trying to see how many people were going from a city to another using the highways, and they have a more updated data than we have used. But I'm not sure if they're doing this within the city as well. But if they're doing, of course, this kind of data could be used to this problem you have stated about the adjusting supermarket stores and so on.
Livia says, I am from Bahia and I see a complicated issue regarding access to data, since much of what happens regarding the migration of the Sao Paulo virus to the municipalities of Bahia, especially Feira de Santana, has to do with clandestine road transport. Do you consider this in your research?
No, we haven't. And actually, this is something that I was told in the very beginning of the pandemic, and I forgot actually to keep doing it. One of our collaborators, a geographer, Dr. Jussara from Fiocruz, she told us that actually cargo is one of the important aspects of disease transmission, could be actually one of the important aspects of disease transmission as well, because we have lots of cargo coming from Manaus and from other important cities that are transported across the country. And if we had a way to keep track of those cargoes, they could explain something as well, of course.
But I don't know, you'd probably have to check now with research being done in medicine and to see if really the transmission through objects is really relevant. It seems that by now they believe that it's much less important than the transmission that actually happens from person to person. Although, I mean, it's still very crazy. There's a lot of data that they still do not match well, and therefore we shouldn't just reject some possibility only because there is already some research pointing out in a different direction. Francis is asking you, Vander, do you think we can use this data to prevent or reduce impacts from a second wave of COVID-19?
Yes, somehow. Yes. Of course, those cities that are more connected and have higher flows of people, they are more likely to receive the cases first. But we have to relate this to the data of COVID-19 to make sure, of course. But yes, this framework we have used could be important as well.
And then Gilliard is asking if you have any public code repository. If not, if you want to make data available in those repositories.
Yes, this is something I have to do. This is in my to-do list, and I will do this in the next few weeks for sure. Yes, and we have another paper that is being now reviewed, in which we created a repository, and we will try to grab all those repositories in one single account and make them available.
Mm-hmm. Yeah. Anna has a question that I believe it's even more to the other. There are many professors here, you know, Vander, it's not as well. So yeah. I know that at least 5 or 6 professors that I've seen around here. Now I only have the picture, so I can't tell. But she's asking if, in our experience, the lack of data, of extensive databases is a problem. I would say it definitely was a problem in the past. Now I think we're starting to get to that situation that we definitely do have a lot of data to be analyzed. Possibly even more data than we have the strength to do. This is what Vander is saying. They are outnumbered in the sense that they needed more people to do all the analysis that they would wish. And I would say with all the open data that we have available today, this should not be our excuse not to develop a good research. I don't know if anyone else has any opinion on that, or at least any hint on that.
Yeah, just to complement your comment, there is this international movement of open data. So I think that now we might have more data about research, and I think there are a lot of repositories in which you can download data from Harvard, for example, and also you have data from Google Dataset. So you can download data from there and you can use it. But in the past, it was very tough to do it. At least in many of my PhD.
Here, I see at least Pepe is there. I think Gabriel is still around. Could you report on how open data is, the open data movement is in your countries, in Peru and Uruguay, and just say if that's feasible that you use that kind of data to do research in your countries? Very briefly before we go.
Let me, I don't have a camera, but I guess you can hear me.
Yes, I can hear.
Okay. I can report a little bit about Peru, although I haven't been following exactly what's going on with open data. I believe that starting with the outbreak of this pandemic is when the government started to gather and publish open data. So now we have a very nice repository. I don't know, for those of us using that repository, we would like to have more, but I mean, compared to what we used to have, there is a lot now. I don't know, I cannot make a comparison with other countries because, to be honest, I haven't been looking at what open data you can find in other countries. But as you were mentioning, yeah, there is a lot of data now. There is a lot you can do. And actually, people are using that data and they are creating very nice public websites where you can follow for example, the number of people infected by COVID per, not just per region, but actually to your local, very local government. For us, it's districts, which is a small portion of a small geographic portion of the country. So I mean, like, for example, I live in the district of Miraflores. Now I can check how many people was tested positive since the very beginning, you know. So that kind of, and this is not only, I mean, I'm giving you the example of COVID-19, but now I can see expenses. There are many things that it's already available on actually an official government website where you can download official data. Okay. Well, that's about Peru.
Thank you. Gabriel, do you have any insights from Uruguay? Since I don't know if you're trying to say anything. If you are, you're muted, or otherwise. Anyone from any other country around?
May I?
Oh, Violeta, go on.
How are you? This morning I was in a session from the cetic.br, and there was a speaker from the Financial Times and a person from I think IBGE, the National School of Statistics. And what they said is that now we have plenty of data, and not only from the government, but also from the non-NGOs that started to provide themselves from different ways. They started to gather data. And so what we have now is, like you said, a lot of data. And now we have to use that and analyze. And even the Financial Times, they said they have a lot of data that can be used, that is open to be used, and they have data from all around the world. And it was amazing because they are using some visual maps to show how the COVID has been evolving from one side to another, and using colors, very fancy graphics. It was really nice. And they also how they are mapping how COVID has been. Now they are waiting for the second, third waves, and it can be followed by the graphics by color. It was really interesting, I thought, and probably many people don't know that we have access to this data. He said that it's open and it's accessible, so it was really interesting. So now that's the problem. We have too much data.
Right. So Anna, your question, the answer to your question is there. There is plenty of data. There is no excuse that you're not going to find good data to work on in your research. Vander Guillermo has another question there. Do you think that there is a correlation between the cities that are more connected and the number of deaths due to COVID-19?
I cannot answer this question precisely because I haven't tested this data, but it's probably there is, of course. And still regarding Anna's question about the data, actually my PhD I did at INPE, National Institute for Space Research, so you know about INPE, and they have very reliable data there, and there are very important people that don't know that all the data is available, and the data is reliable, and it's being tested by the whole world actually in their research. So yeah, we have data. Yeah, that's it.
Okay. Andrea has a question there. Do you think that with a similar approach and a bit more data, we could create a timeline network for the spread origin of the COVID-19 cases?
The problem is that we cannot go to the past. The problem actually with the data regarding COVID-19 is because every single city has its own public health surveillance system. So they feed the federal system with the data they have. But of course, the hospitals that we have in the city of Sao Paulo, they have infrastructure and they have how to track all the cases and feed the system with reliable data. They have, I'm not sure actually, but they could have more tests to apply on their patients than some small and poorest cities of the country. So the differences between the data that comes from each city can be very huge actually. So the data, although we have the data for the entire country, of course, some places have better infrastructure and equipments to give better data than others. And I'm not sure if we can create a timeline because, as I said, we cannot revisit the past. If we had, for example, thousands of tests being applied every single day from the beginning of the pandemic, getting, for example, samples of the population, of course, the data we had would be better than we have now. So this is the problem. We cannot go back.
Yeah, we cannot go back, and we haven't ever tested enough in Brazil. That's possibly also the case. So we don't have exactly that data of how things are evolving, except for the numbers of those numbers of people that actually go to the hospitals or somehow get noticed by the health system.
Yeah.
All right. Okay. I think those are the questions we had. Maybe Flavio, do you want to go back to the last slides, those ones in which
Yep.
you have the final?
Let's go for the last slide.
I don't know if you're going to formally thank Vander there, but maybe we could already informally thank him here, right? And clap our hands virtually, or I never find it.
Let's do it.
Okay, thank you very much.
No, I mean, it was a very good, Vander. Thank you very much again for the presentation and for making it in a short period of time. 2 hours, very tough time, but I think that we all enjoyed your talk. The topic is very important as well. And yeah, so thank you very much for doing that and accepting the challenge again.
Yeah, we have to tell everyone. I mean, we plan everything a lot in advance, but there are some contingencies that happen in the middle of the way, like the problem that we had today that we have to very quickly adjust. And thank you very much for that. It was really great. This is really good teamwork when one of the authors cannot present and the other comes and does such a beautiful job.
Exactly.
Okay, anytime. Thank you.
Yeah. So yeah. So for the last slide or last comment that I have. So just these are more like points to be for your attention for the next steps. So again, just don't forget to register your attendance using the link. I think Alexandre shared on the chat. So it's really good that you do it so we can issue the certificate.
And by the way, if anyone has attended the previous ones and for some reason did not get the certificate, send me an email and I will see what happened. Right? But it's basically we send the certificates based on you filling in the form during the presentation. So you have to go there right now or right after we finish here and say that you were here with us.
Exactly. I think you actually closed the link, no? Or how is that?
Is it closed? Oh,
no. I mean, how you close the link, or you just select the people who's in the time frame from.
No, I select the time frame. I select the time frame. Of course, if someone tells me next week that they were here today, it will not be considered.
Okay, perfect.
Okay,
Yeah,
Lucas, Lucas, please send me an email and I will see what happened.
Okay, so last, just go to Moodle and write and share your thoughts about today's seminar. I think that this is more for the UTFPR and people who attended at UTFPR. And in the case of UFABC, you have to write your post summary. I saw some comments from the summaries that you are actually submitting, and I promise that I'm going through all of them until the end of this week. I'm gonna try to do it, but I have lot of stuff on my back, so I'm trying to do this one by one. And this is on my pipeline, so I'm gonna do this until the end of the week. So prepare for the next seminar. I think that we should already share the paper. I think that we don't have video for this one, but we have a very nice paper from Marcelo Fornazin, which is also from Fiocruz and the Federal Fluminense University. I think that's the right name. And we're going to still talking about health, but not about the coronavirus, but it's how to use ICT, information communication technology, in healthcare systems. I think that it's something about I think it's something about hospital, or how can you use technology within hospital to monitor the patients, and how can you track the attendant, how can you track the first attendance of the patients. And very interesting talk as well. It's going to be a very interesting talk and also a very interesting paper that we're going to go through in the next seminar. I think that's all.
Okay, well, thank you very much, everyone, and see you all guys next week.